Alright guys, we're back together again. Unit 5, Skill 4, Justify Triangle Similarity. This is Miss Griffin taking a look at how to justify triangles are similar. It's similar to proving triangles congruent, except that it's not, in the fact that the triangles are similar and not congruent. So our essential question, hopefully you've been writing as I've been just babbling here, how can we justify whether or not triangles are similar? There's 3 ways to do this. Grab a highlighter if you have it. We have it's AA. AA similarity, side similarity, and SAS similarity. Now, I do want to tell you that AA similarity can also be used with AAA similarity. I know you've heard all your life in geometry that AAA is not okay. We've been saying it over and over and over, but it's different for similar triangles. So let's just write this off to the side. Could also use AAA similarity, but we only need two sets of congruent angles. Well, my handwriting's actually neat for once, maybe a little neat. So remember that similar triangles have congruent angles. No matter if they're big triangles, small triangles, it doesn't matter. I've given you this example before. I think an equilateral triangle has all angles of 60, no matter if we dilate it by a scale factor of 10 million or a scale factor of 1/5. It doesn't matter. The angles are still 60 degrees. And you can see that all 3 pairs of angles are congruent. However, to prove triangles similar, we just need 2 pairs of angles congruent. So here, AA similarity can be used when you can prove 2 pairs of angles congruent. So sometimes this comes from parallel lines, like alternate interior angles, corresponding angles. Other times it just comes from vertical angles or reflexive angle that's in both triangles. It just depends on the picture that's given to you or the markings that they tell you to mark up. The next one we have is side similarity. It's different from congruence because here this is where all 3 pairs, notice it's 3 pairs, of corresponding sides are proportional, not congruent to one another, but in proportion. So we will have to check proportions to make sure that they work out when we cross multiply or when we reduce. The last one is side angle side similarity. Again, different from congruence because the corresponding sides, 2 pairs, are in proportion, or are proportional rather. Same thing, it's just the grammar. Are proportional, and the angles in between the 2 sides are congruent. So this would look something like this: side, angle, side, with like maybe a 3 and a 4 here, I don't know. And then a bigger triangle, scale up by a factor of 2, and we get 6 and 8 with a pair of angles in between them that are congruent. So this first question came from a Common Core exam, I believe. If not, there was one definitely similar to it on there. You can see your steps listed off to the side. It says draw a picture if one is not given. Clearly, there is no picture in example 1, so we're drawing ourselves a picture. We have triangle ABC. I'm going to draw another triangle just like it, except bigger. And this is DEF. It says that AB is 6, I skipped AC. AC is 9, DE is 8, DF is 12, and angle A is congruent to angle D. So you have to mark those congruent, otherwise we won't be able to figure out what similarity, I can't think right now, what triangle similarity we need to use. It says determine if the two triangles are similar and explain your response. Step 2 says list your options for triangle similarity. So that would be like AA similarity, or SAS similarity, or side similarity. Now clearly here we don't have 2 pairs of angles that are congruent, so we're going to cross it off. It looks like we have a side angle side going on here. We don't have 3 pairs of sides, so we're going to cross it off. So we're looking to try to get side angle side similarity. So based off of this, we're going to check the proportions for the sides. Remember, you can either go big triangle over small or small over big. It doesn't matter. You get to choose. So I'm going to choose to go small over big. Just because I drew the small one first, I don't know. And we're going to match up the corresponding sides. So for example, AB matches with DE. And you can stack your letters to be certain about that. ABC, DEF. Right, so AB matches with DE, so we're going to go 6 over 8, equal sign with a question mark, because we're checking the proportion to see if it's true. And then AC matches with DF, so we have 9 over 12. Again, small triangle over big is the way that I chose to go. I want you to get in the habit of reducing your proportions when you're checking them. You could cross multiply. That's a totally, entirely valid option. However, it's going to be a little difficult on the next page to cross multiply when we have 3 sets of sides, because then you have to cross multiply multiple proportions, and that's more work. So if you just simply reduce them, your calculator is great at reducing fractions. If you can't recall how, just type it right into your calculator, hit enter. So 6 divided by 8 turns into 2/3. I'm lying to you. It turns into 3/4. Right? You divide the top by 2, divide the bottom by 2. Then 9/12, if I divide both top and bottom by 3 in this case, turns into 3/4. And we see that they're equal, so we put a check mark, and you can put an equal sign in between them now. So then we have to say whether or not the triangles are similar. If the proportion worked out, we would say yes, and then by, and which one of these 3 options is it? Well, this one came out to be side angle side similarity based on the markings. We had 2 pairs of sides in proportion with the other 2 corresponding sides and a pair of included angles. So this is SAS similarity. Notice that over here it says that yes by blah 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 for your final answer and no because corresponding sides are not in proportion. So if it's a yes, you just say the similarity option. If it's a no, you have to say because the corresponding sides are not in proportion. If you haven't already highlighted that, please do. At the bottom here, example 2, it says we have sides that are parallel. AC is parallel to DE or DB. Determine if the triangles are similar and explain your response. Notice that they have ACE stacked with BDE. So angle A should be congruent to angle B, and take a look at this. If I outline a Z, angle A gets encompassed and so does angle B. So I'm going to just make a quick statement about that. Angle A is congruent to angle B. And this is because bringing it back, alternate interior angles are congruent when lines are parallel. This is part of the explanation that you need. I'm sorry, but you do. We could also talk about the other pair of alternate interior angles if I go for a Z this way. So angle C with angle D. Or you could even use vertical angles, which I'm sure that some of you guys saw in here immediately. These vertical angles are congruent. It doesn't matter to me what you talk about. I'll just talk about vertical angles because I still have purple on my pen. Angle, let's do 1 and 2. I'm going to label it in the picture. Angle 1 congruent to angle 2 because vertical angles are congruent. And then, yes, the triangles are similar. Well, we have 2 pairs of angles congruent. We even have a third pair, remember, if we want it, but we don't need it. So 2 pairs of angles congruent gives us AA similarity. Flip it over, we're going to see another potential option, and then triangle similarity transformations. Kind of cool. Alright, so I want you to pause the video, label this, and then I want you to set up proportions. A bunch of fractions with question mark equal signs in between them. When you're ready, hit play so that you can see whether or not you have something similar to mine. Then we'll check to see if the triangles are similar together. So again, pause, label, set up proportions, and then hit play. Alright, so I've got my proportions set up. I just want to talk you through it real quick in case you were struggling. I stacked my letters first, A, B, C, X, Y, Z. I decided that I'm going to highlight my sides, and you can see that with different colors. A, B corresponds with X, Y, so I highlighted them in red. B, C, Y, Z, highlight them in blue. And again, this all comes back to my stacked letters, B, C, Y, Z. A, C, X, Z in purple. This is a helpful tip for those of you that are struggling to match up your parts. I decided to go big triangle over small because I saw the big one and the small one. Big on the left, small on the right. Doesn't matter. If you did big over small, then your numbers should look like this. 3 over 2, 12 over 8, 18 over 12. If you did small over big, I guess I should have had this written out for you. You would have had 2 over 3 to 8 over 12. Just flipping the fractions upside down, that's all. And 12 over 18. Okay, so I'm going to take my big over small, because that's what I did first, and reduce them. Simply type them into the calculator and get the reduction. 3 over 2 does not reduce. Nothing's in common with top and bottom. 12 over 8 I can divide by 4 to give me 3 over 2. 18 over 12 I can divide by 6 to give me 3 over 2. These are all equal, so it's checking out. That means yes, but we have to think of our three options. Remember, we didn't list them out at first, and we should have. AA similarity, SAS similarity, or side similarity. So in this case, it's SSS similarity because we have 3 pairs of corresponding sides in proportion with one another. If you had reduced your fractions and you did small over big, these would have all reduced to 2 over 3. So same response, even though you did small over big. Remember again, if your answer comes out to be a no, you have to say because corresponding sides are not in proportion. We only get side because the corresponding sides are in proportion, so it's just the reverse of that otherwise. All right, example 4, last one here, and then I'll let you go until I hit you with the next video. Identify the sequence of transformations that justifies the triangle similarity that maps triangle DEF onto triangle D prime, E prime, F prime. So clearly these two triangles are different sizes. One's bigger than the other, so I think you know that something has to happen as far as shrinking or growing. But there's also an additional transformation that has to occur because D has to bounce over here. F, well, it kind of stays in the same position, and E, once it shrinks, will be in the same position also. So if I'm bouncing D over here, I'm flipping it. It looks like flipping the entire triangle over. If I flip it over, it'll be somewhere like this, which I think is a good thing. So first, we're going to say, flip is a reflection over, and in this case, it's the y-axis. So I want you to actually draw that, reflect it over the y-axis, so you might want to highlight like you see me doing with my purple marker. E is going to stay where it is because it's on the y-axis, so will F, but D is the kicker here. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so now I have this new triangle in purple, nice and pretty purple, and I have to get it to be the size of my yellow triangle that you see on my screen here. So we have to shrink it, which means that it's a dilation. And it's a dilation by some scale factor, and in this case it's centered at the origin. And that's because you can see that F stays the same. So it's coming out, branching out of F, and F is at the origin. If we take a look at this point out here, I should use my marker here, or my laser pen. This is at 4, 0. D prime is at 2, 0. So we're shrinking it from 4 to 2. We're not subtracting, remember. Because if I try to subtract from 8 down to 4 for E to E prime, that doesn't work. How do I go from 8 to 4? By multiplication. Well, that's multiplying by 1/2. So it's a dilation of 1/2 centered at the origin. And it does say to justify that the triangles are similar. So the triangles are similar by a similarity in this case, because dilations and reflections preserve, don't say distance because we're talking about similar triangles. Preserve angle measure. Remember, dilations don't preserve distance, but they do preserve angle measure. So in this case, the triangles are similar and only similar. Okay, that's all we got for you. Remember, set up your proportions and just reduce them. Don't worry about cross multiplying because, again, in this example up here, you would have to cross multiply 3 different times. One here, and then with 1 here. So if you just simply reduce, you're going to be better off. It's going to take you less time. All right, catch you later. Good luck. Let us know if you have any questions.